Hello and welcome back to part number 3 in the multi-part tutorial for C# asynchronous sockets. In the last tutorial, we basically went over creating the client, handling the packet server side, and we also went over how to build a packet. This is a really basic packet, and you just simply send it, and that's kind of all there is to it, and it's really nice. So I mentioned last time that there's a much easier way of creating packets, and there is. I mean, don't get me wrong, like, this might not be a lot of code at first, but I mean, imagine you're writing stuff like, a character name plus their ID plus if they send a message and who it's to, who it's from, what the message is, and it just gets to be a lot of data. And so we want to build something to handle all this data for us. And that's where, our packet structure comes in. So I just want you to remember the bit converter class. And this will convert, numbers, booleans, and stuff like that into bits. And, yeah, to convert strings, you can use, damn it. You can use the encoding class. So here you can just type in hi, and it'll dump out the bytes for hi. I like to use UTF-8. So basically what it is, it's the encoding class dot whatever encoding dot whatever method you're using. I like to use UTF-8 because it's a really global kind of thing. I mean, a lot of people still use SCII. I don't know, it's just whatever floats your boat. If you really want to know, like, if there's any pros and cons, go research it yourself. But I like using UTF-8. So there's those classes to remember. And of course, array.copy, which copies your array to another array. So yeah, that's kind of it. I'm going to delete this, and I'm also going to delete that. And we're going to begin working on our packet structure. And this is part of networking. And it's literally what it is. It's how your packet is structured. So that's how I'm going to write it. I'm making this class inheritable because inheritance is awesome. You'll understand why. If you don't understand inheritance, just follow along. I'll show you how to use it in this way. But I strongly recommend you look up inheritance because it's amazing. Just really awesome. And to make a class inheritable, you put it as abstract. And so every single packet that we create is going to have a length, and it's going to have a type. And it's also going to have a buffer. So once we have the length and the type, we can create a new byte array and specify what its length is. But now we need to write the length and the type to it. And in the previous tutorial, you saw me using bit converter. I had to make a lot of arrays and stuff. But there's actually a lot easier way to do that. We can write our own method to do it for us. So every uShort basically needs to have, the value and the offset. And what the offset is where in the packet you want to write this. So a U short is 2 bytes, so remember that. Once we have what we want, we have the value, which is what we want to write, and we have the offset. And now we can copy this. And that's basically how you write data. I mean, this is, like I said, you know, instead of having to go through all this code every single time, and all you have to do is just that, and it makes it really nice and simple. There is another method of copying, and that is the buffer, and you want a block copy. In this case, it'd be temp buff, start at the beginning, copy it into buffer, start at the offset that the user specifies, and you write for 2 bytes because that's how much a U short is. I mean, you can use either method you want. You've seen me use array copy many times, but I actually like buffer better because I feel as if it's more explanatory. That's just how I feel about it. So, you know, that's your writing the U short method. So now all you have to do is, if you want to write the length, okay, well, the value we want to write is length, and we write the length at the beginning of the packet. The next thing we write is the type. That's the value, and when we write it at slot number 2. And that's because, you know, it's just how it is. For me, that's just how I have my package structured. And, you know, you can go ahead and, you know, write your whatever you want. I'll probably do one more just so you can, you know, see how it's done. Again, you basically create a temporary byte array, and the size you give it is whatever size your variable is. A U short is 2 bytes. 2 U shorts make up a U integer. So 2 times 2 is 4. Now we need to get the bytes from whatever the user entered. So you get you put value in there, and it knows that it's a U int because that's what value is. So there's no casting needed or anything. Once you have your value, you just copy it over, starting at the beginning of that temporary buffer. You copy it into buffer at the offset for 4, you know, 4 bytes. Or what you could actually do, never mind, you can't do that, I guess. But yeah, that's basically how it's done. Like I said, you know, you might be able to clean this up a lot. You could, you know, what you could do is wipe the value from the buffer and then write it. I don't know. You could do whatever you want, but this is just the basics of how to get it done. So you have this packet structure, and you're saying, okay, so what do I do with it? Well, you have to start creating packets from it. So within networking, I'll create a new folder called packets, and I'll make my first packet. This packet will be the message packet. And in order to send a message is a string, so we'll need to add functionality for strings. So what a string is an array of characters. A character is one single letter, such as A or B or C. A string is multiple characters. CAT makes the string cat. So you want the length of the string, because one character is 1 byte. So if there's a string that's 20 characters long, it's 20 bytes. And for strings, we need to use encoding. And it's just making these is just really easy, I feel. Sure, you could mess up with it sometimes, and there's definitely better ways to do this. For example, buffer and array, when you copy using buffer.blockcopy or array.copy, it's actually pretty slow. I mean, you don't really think of it that way because the computer just runs so fast, but there's Marshall copying and literally copying like segments of an array to another segment of an array, and these ways are much faster than buffer.blockcopy and array.copy. But buffer.blockcopy and array.copy are very easy to use. So for that reason alone, I use them, because I don't write applications that you need, I don't write applications that require a super low ping, such as a video game and stuff like that. Otherwise, I would use Marshall and stuff like that. But for now, this is good. So once you can write strings, what you want to do is make a new packet. To inherit from another class, you put a colon and write the name of the class you want to take from. In this case, I want to take the packet structure. You start with a constructor, but you also need to add the base. The base is basically saying, okay, this is the constructor for messenger, and this is the constructor for packet structure, and you need to fill out the data here. It's asking for a use short, or it's asking for the length and the type of the packet. Well, message is going to ask for a string, whatever you want to type. So for the length of the packet, we put 4 plus message.length. And the reason we put 4 is because we already know we're going to write the length, which is 2, and we're going to write the type, which is another 2. That makes 4. And then we need to add however long the message is. So that's where we get our length from. The type, I'm going to have this be packet type 2000. I don't understand what the big deal is. There should be no big deal. I honestly don't know why this is not working, because it really should be working. So I'm just going to go ahead and continue for now. So anyway, once you have the message, you know, so basically there's a message. There should be absolutely no problems, and I can't understand why. Well, basically you understand what I'm trying to do. There we go. What the hell is going on? This is not an integer. I don't really... This should be fine. Yes, it's fine. Okay, so this is... man. That shouldn't be necessary. So here we go. This is basically what it's doing is you made a new packet type called message, and you have it say, okay, I'm also a packet structure. Then you make the constructor for both of them. A message takes a message, and the packet structure requires a length and a type. For the length, you put 4 because it requires a length and a type, which makes 4 bytes, plus however long the message is. The problem I was having is I had to cast a U short. I had to do the math, then cast it all to use short. So that was my problem there. And basically that's kind of all you need, really. Sorry. There's actually one thing. Is I have basically all you need is this right here. And you don't need to put this, because instead of this you could put write string value 4, or write string message and then 4. But I have this so I can access what the message is, and I'll show you exactly what that means. I know I'm probably really confusing, but just follow along. Having a bad time. So let's go back to the program. So every time we type something in and we press enter, what we want to do is, damn it. See how we've created a new packet like that? Yeah. So basically it created a packet of type message and it put the message in there. There's one thing you do need. There we go. So what I just did was I changed the socket and client socket from private to public so we could access it outside of this class. And I added this get method because we have no way to, I don't know why that says that, but that's wrong. Oh, never mind. The reason I made data was because there has to be a way to get the buffer. So what you can say is, you know, client socket I'm sorry. I'm setting the socket back to private. That's what I needed to do. Sorry about that. So yeah, now what you can do is you can just client socket dot send packet dot data, and sure enough, once I run the server, and I run the client, and I wait for it to load and do its thing. And it says, hey, I connected to the server. Now watch. I will type something like, hey man, this is message packet. And it received the packet. So it claims, and it's of type 2000. So that's how you get started with packet structures. And the cool thing about this packet structure is once you develop a packet structure, you can use it for both your client and your server. And I'm going to go ahead and push it to 30 minutes, screw it. And I'm going to show you what I mean. So, and you can actually take the packets too. You can take the packet types you make. For example, I want to copy this packet structure and paste it into my other thing. Now I have that packet structure, or the packet structure, yeah, sorry about that. Did I just, yeah, my bad. I meant to copy the packet structure. The only thing you need to do is change the namespace, and boom, it's all good. So now we can begin handling packets. If you make a switch here, or you can do an if statement, but switches are obviously much better, and you want to switch the packet type because you're trying to figure out which packet type it is. If it's of case 2000, that means it's a message. And yeah. So we're going to go ahead and make a little addition to our packet structure. Because we don't want to just write, but we want to be able to read from it too. So in order to do that, we build our methods. And that's how you do that. So not only do we want to be able to create packets, but we want to be able to read current packets. So, once we get the packet, that's all we got to do. And that's how we do that for the string. So, in our message packet, this is our constructor to create packets. So, we must also need one to read packets. Oops. Sorry, I forgot to update my client's packet structure. So this will for sure get us the data we need to know. So anyway, so you've learned how to create a packet structure, you've learned how to construct packets, you've kind of learned, you know, how to write and read from byte arrays or packets, and you've learned how to create packets using your packet structure. So let's go over this real quickly, because I know this was a really confusing tutorial to follow because I just, you know, kept messing up. But basically is you have this packet structure, and this contains all the data that a packet would need. It has the byte array, it has methods to read from your byte array and to write to it, and it also has a way to actually grab the byte array, and it's called data. So when you send a packet, one of your packets, to the other person, you use socket.send. Socket.send takes a byte array, so you can do socket.send packet.data, and it'll send your byte array. So we have a packet structure, and we have, in our networking, we have a subfolder called packets, and this will contain all of our packets. The first package we built was a packet called message, and what we said was, okay, this packet called message is a packet structure because it's a packet. It follows our packet structure. So we said, okay, well, if we want to write a message, this constructor will take a string called message. And once we have our message, we have to call the packet structure constructor. And for packet structure, it contains a length and a type. Once we do that, we can write our message to the packet. If we already have a message and we want to see what it is, then we pass the packet we received, which is of type message, and it gives that packet to packet structure. So now we can read it. We can see what text is. And so you know I'm not pulling your leg or whatever. We will do that. See? Read everything a-okay. So I know this one was really long, and I know this one might have been confusing, but you know, just try to follow the best you can. I'm not really the best person to explain things, especially stuff like this, but I thought I did a pretty good job, and I think you should be able to understand pretty easy what I'm talking about. Because this actually concludes our tutorial video, so I guess I'll use the next 5 minutes to explain and stuff, because this is Networking 101. you know, you have a packet structure. I mean, the first step was creating your socket system here. You created one for your server, so you made it start binding, listening, and start accepting clients. You told it what to do once it accepted a client, and then you told it what to do once you receive a client, or once you receive data. You say, okay, grab that data and do something with it. With your client socket system, you said, okay, we want to connect to where we want to, where we specify. Once we connect, we want to make sure we're actually connected and it's not just telling us we are. And then we begin receiving data, if there is any to receive. Once we have received data, we grab the data and we handle it. I didn't make a packet handler for client because you just copy what you did for server. So, you know. And then I added this optional thing in here to send data, because for the client it's going to work differently for the server. For the client, you're only connected to one server, so you can use that socket because that socket is your connection to the server. Any interaction you do with other clients is because the server has passed that data to you. So at all times, you're not connected to another client, you're connected straight to the server. So you can use that socket up here to send data with. So that's how the client socket system worked. Once you built a socket system, you had to handle the data that came in. So, you know, you got the data and you have, you know, the client's connection, so you can send information back. And, you know, you got the length of it and you got the type, and you told yourself what you got, and then you began handling it by using your custom-made packet structure. But before you handle it, you know, to make things easier, you had to make a class to handle it for you. So then we built a packet structure. Within our packet structure, we have the packet itself that we can read from or write to. If you are creating a packet, you specify how long it is and what type of packet it is, and then it writes it for you. If you want to read a packet, all you do is give it the packet, and then you can start reading from it. If you want to get the packet itself and you want to do stuff with it, you have the byte array of it right here. It's called data. Packet, whatever packet you're on, dot data. And then you said, okay, well, I have this packet structure, so how do I use it if it's inheritable and I can't, like, use it? So you made a new packet called message that says, hey, I'm a packet structure, and you began to do stuff with it. You said, okay, if I want to create a message, I need what that message is, and I need to specify how long it is and what type it is. Well, a packet is going to be at least 4 bytes long, because the length is 2 and the type is 2, so that makes 4. Plus, it's going to be however long the message is. And it's of type 2000. Then you say the text of the message is what the user put, and then it writes it to the packet. If you want to get a message and see what was said, you say, okay, here is the packet, the message packet we received. And the packet structure takes it and stores it so you can use those reading methods. So you just do message.text and it will read what the string is. And that's basically what you've done. Now, there are some things you could do differently. For example, if you're writing a message packet for example, what I strongly recommend you do is you write, you know, how long it's going to be, and you write the type. The very next thing you should write is how long the string itself is. So instead of doing 4 plus message length, you would do 6 plus message length. And instead of writing it in slot number 4, you would start writing it at slot number 6. And you would read it from slot number 6. And that is because if you have a packet that says, okay, here's the length, here's the type, here's how long the sender's name is, here's the sender's name, here's how long the recipient's name is, here's the recipient's name is, here's how long the message is, and here's how long the message, or here's the message. And you want to do that because if you don't put how long stuff are, how are you going to know where to stop reading and where to begin reading? Because, you know, a person's name can be between 3 characters and 8 characters. So, you know, you want to make sure that your packet stuff knows how long everything's going to be. So instead of doing data length minus 4, I could just do read u short 4. Because, you know, I put how long the message is at slot number 4. So I'll read starting from 6 for however long it says to in slot number 4. And that's just kind of how that works. It's pretty basic stuff. You should be able to understand it. This video is going on for an extremely long time, so I'm going to quit here. But yeah, this is everything you need to know to start networking. Like literally, you can make a chat system with this. You can, with Windows Forms, you can make a literal GUI and start making a chat system. There is one thing I do want to say about the server socket. Is the reason, basically what's going on here is you want to make a class to store all your clients' information is. You want a class to store their ID or their IP address. You really want to do an ID thing because basically you want to have you're going to want to have a dictionary, and it says, and you store all your clients in it. So if a client sends a message and it's a public chat room, you can do, for each client that's connected to you, you send them what this person has said. And in order to work, like in order to do that, you're going to need to store all your connections in a dictionary or list or whatever you want. You might not understand what I'm talking about, but you'll definitely understand if you try to do a fully working chat system with just what I've showed you, like taking this and working from it. Yeah, like I said, you need to, if you're a server, you need to store each client's information and make sure you can identify which one it is. That's why I suggest having a database or a flat file system, and you store accounts there. You know, they have to log in to get their ID, and then they send an ID with every packet, stuff like that. So that ends this tutorial, and with that, I'm signing off. Good luck.